Hey everybody, welcome back to another video. In this video, we'll be talking about transfer learning and using state-of-the-art CNNs to help train our skin cancer detection dataset. This video will also be the last video in this three-part skin cancer detection series. As of right now, I'm currently thinking about using CNNs for math equations, something that's on my mind that we can potentially try out next as the next series. But anyway, let's just get started and let's talk about transfer learning. So the gist of transfer learning is that transfer learning is basically pre-trained models that have been trained on various images and datasets that have achieved state-of-the-art results. So for example, one of the datasets that are commonly used is known as ImageNet. So ImageNet is a dataset that consists of 1,000 classes and has more than 14 million images. And there are many different models that have been trained on this dataset. Some of the ones are known as like MobileNet, for example, and ResNet. So these models are pre-trained models that have achieved state-of-the-art results on predicting on around 1,000 classes, which is insane. Okay, 200. Some of them have 1,000 classes or whatever, but these models are very well done and they're state of the art. So we can also implement these models in our example of skin cancer detection. So we can talk about implementing a model known as a MobileNet. So MobileNet's another special type of model that's been used in the ImageNet dataset and has achieved some really good results. So anyway, that's enough talking. Let's just get right into coding this out. So the first thing we want to do is import a library known as TensorFlow Hub. So import TensorFlow Hub as hub. If you don't have TensorFlow Hub, make sure you do pip install TensorFlow Hub because it's not included with TensorFlow. So you need to do install this separately. We can also get rid of these layers. Conf 3D, max pooling 2D. We can get rid of activation. We can get rid of dropout as well. There we are. So now that we've done this, and now that we've imported TensorFlow Hub, let's just get right into it. So with MobileNet, MobileNet requires an image size of 224. So I'm going to be changing that up right over here. And now what we can do is we can completely get rid of this model. Like the model architecture that we built here, we can just completely get rid of it. And now what we can do instead is we can define a URL. So basically TensorFlow Hub is like, you could say like a GitHub repository where it has a bunch of different pre-trained models there. And what we can do is we can use a bunch of different models. So let's take a look over here. Notice like TensorFlow Hub site has everything. Fine. So they have everything, like from bird to object detection, style transfer, whatnot. So we're going to use this model from MobileNet. It's MobileNet v4. And yeah, feel free to copy the URL link over here. I'm going to put it in the description. So if you guys would like to follow along, but yeah, this is the path. You can just like copy this, go to TensorFlow Hub, paste that in Google, and yeah, you'll just get it right here. So anyway, so yeah, copy this link over here, and now what we can do is going back to VS Code, we can specify that to be URL is equal to this URL. And now what we can do is we need to download the model onto our computer. So by calling download model, so it's just a variable. And now we can do hub.keras layer. So now it's just a keras layer from TensorFlow Hub and pass in the URL, and our input shape will be equal to image size by 3. Okay. So now that we've done that, the model will be downloaded. So yeah, as of right now, we've imported the model, and now what we can do right now is start defining our model. So we would do model is equal to sequential, and we'd put our download model here, download model. And now that's also now with the model, it already has its pre-trained conv layers, or its max pooling, dropout, and whatnot. So now we just need to call out the output. So the output is going to be 2 classes, right? Benign or malignant. So we need to specify that. So dense of 2, and we also need to call our activation of softmax. So yeah, now that we've done that, this is our beautiful TensorFlow model here from our MobileNet model. And now what we can do is, as of right now, our model is currently ready to train. Before we do that, let's also print out our model summary. So this kind of shows the shape of the model and all the layers. So print model summary, and then we can do something like this, print model.summary. Let's just put a new line over here. So to make code a lot more cleaner. And let's also comment this out. So now that we've done that, let's open up File Explorer, go here, over here. Okay, so now let's call on CMD, and okay, let's drag this over here. There we go. So now we can do py main.py, and let's just wait for it to load. There, let's zoom in a bit. This model's loading still. Okay, there we are. So this is our model, a very beautiful, a very nice model, as you can see. So this is our Keras layer, right? This is our model, and this is the mobile.net model that we're downloading. So notice here that we get 1001. So that's like the output classes. And now what we want to do is we want to change that to 2. So that's exactly what we're doing here. And now that we've taken a look at our model, we can also start calling model.first. So now we can start training our model. And let's just do that right now. So I'm just going to copy paste this. Model.train. Let's do this. Model training, just to make the code a lot more cleaner. And now what we can also do is, after training our model, we can evaluate it on our test data set. So we can call something like model.evaluate and test data set. So that's exactly what we can do. And we can also copy paste this. Model evaluation. And yeah, let's just run this. We can do one more thing actually. We can also save our model. So what happens is, after we run this TensorFlow script and we have the model trained, sometimes what might happen is, if we want to use our model for predictions or whatnot, like, we don't want to train the model for whatever epochs and then have it load. So what we can do instead is we can save the model and then just directly load it in. So let's just specify that. So we could do like print model save, and now we can just do model save, and we can save it in different formats. You can save it as a TensorFlow format. I tend to save my models as an HDF5, so model.h5, just a trick. And yeah, as of right now, let's just train the model for 10 epochs. And yeah, so I'm gonna speed run through this. So there, so I'm gonna speed this training process up. So let's just let the model train, and once the model training finishes, I'll get right back to you. Okay, welcome back everybody. We're now on our last epoch of training, and as you can see, the model is reaching accuracies of 86%, which is a lot higher than what we reached before while just building our own CNN. And this kind of just goes to show the power of TransferLink, right? This application can be used in endless situations. So just as, a general note, TransferLink is a super powerful thing that we can use in almost any situation. So yeah, and now that you see, right now our model is currently going over evaluation, and yeah, our model is reaching accuracies of higher 82% on our test sets. These are images that the model hasn't seen before, and now after it's now able to predict on the images that it hasn't seen before with accuracies at around 83%, which is really insane. So yeah, we've saved our model now, and you can kind of, if you go to the thing here, you can notice that this is our model right here, model.h5, and this is our file, and we can actually load our model in. So if you want, we can do that right now. So let's just comment this out. Let's comment this part out, and now what we could do is we'll do something like this. So we can do model, or load model is equal to tf.keras.models.load model, and now we can specify model.h5, and now we can just do the same thing. So if I wanted to predict on my test set, I would just do the same thing. So now I would just do load model.evaluate test set, and that's exactly what we can do. So let's run that again. And yeah, this is like an example of like the power of saving files. Just as a general, you can actually unknown file Keras layer. Yep, completely forgot to specify this. But whenever you upload or whenever you use a Keras layer, you need to specify it as a custom object. So whatever you load the model, you need to put like custom objects is equal to keras layer or hub layer, something like this, and keras dot hub layer. Hub layer. tf.keras hub layer. Let's make sure that I am doing this right with a quick Google search. Low tensor flow hub model, and there's a specific way that TF hub model we can use hub.load. That's another way we can do it actually. We can also do something where we use custom objects. So I believe it's something like this. We can actually give this a run. Hub.keras. Let's try this. Let's try this. And yeah, now let's try this and hopefully it works. Let's just actually let's clear our screen and now let's run this. TensorFlow Hub has no attribute keras layer. Interesting. Okay, let's take a look back at VS Code. TensorFlow has no attribute hub layer, so I assume maybe it's keras layer. Let's try this. Let's go back to VS Code, save this, and let's continue. Let's run this one more time, and hopefully it works. TensorFlow Hub has no attribute. Okay, let's just Google this up. Low TensorFlow Hub model custom objects. Let's Google that up. There we go. This is the code. Oh, okay. Interesting to know. I had to capitalize keras layers, so we were not that far off. But yeah, now let's try this and let's see if this works. Py. And hopefully, after a bit of Stack Overflow and Googling, the model finally works. And there we are, boom. See? Now after loading back our model, we're now able to show the evaluation set. So yeah, I think this would be a good place to end off our episode for today. This is the last episode, by the way. So for this 3-part series of skin cancer detection, this was the final episode. So I hope something like this was really enjoyable for you and you were able to learn something from it. And if you guys have any recommendations for what machine learning projects you'd like me to code out next time, then drop them in the comments. And yeah, other than that, thanks for watching. Do like and sub, it will be highly appreciated. And if you have any feedback, drop it in the comments. And yeah, until then, goodbye.